sure what it's was. And
I think it's the wall. Well, let's see. It's very
16 feet? Probably 16 feet.
I brought a tape measure. Let's just find out.
Do you have the motor working?
Although
I do.
That 512 value is suspiciously to the end. It could be maxed out.
512 centimeters.
Yeah. Oh, just 512.
It let's see. It should go clear up to 1200 some.
1024.
1200.
1023.
It'll go to 12 meters. So 12 meters is 36, 38 feet. Something like that.
It's suspiciously topping out at 512.
It's just
it's awful suspicious.
That's all it is.
Can I move it?
Have fun.
I'm moving it.
Oh, okay.
There we go.
Yeah, it goes up above 512.
Cool.
So
it loves the power.
We're at 17 foot. So did you move it about a foot?
Yeah.
Yeah, about a foot, looked like.
So whatever it's seeing down there is, and it's fairly regular. I mean, really. Ow! And then it just decided to kill itself. What the? Oh! You fooled me.
The hand is quicker than the eye.
It's pretty consistent, though. I mean, but I brought a tape measure just in case anybody wants to question it. I believe that it's right.
Let's do it. Hand me the tape measure. I'll do it. Somebody's got to do it. Be official. Is it longer than 16 feet?
I have no idea. This is a 99-cent. This is a 99-cent.
No, it's the length. It doesn't have anything to do with price.
Dollar Tree or Harbor Freight.
This is a 99-cent tape measure from
Harbor Freight.
no,
Dollar Tree.
IKEA.
Oh,
IKEA.
We're maxed out.
Okay, you got it set? Okay.
When you bought it?
Is it where the lens is? That's not
More,
the sensor, is it?
more or less, yeah. It's
Okay, so that's 10 feet. Okay, let her go.
When you bought it?
when I bought it.
That's 11.
Measurement.
That's 5 feet. 6 feet.
It's now no,
16 feet.
16
The
feet.
tape measure, yeah.
Because it's hard to find
16
centimeters.
feet, he's got.
Oh, yeah.
16 feet?
16 feet. It's saying 17.
Okay.
So
Have to change your calibration a little bit. So it's about right at 17 feet. Or 16 feet. And it couldn't be anything further than the wall.
well, it's also pointing up a little bit too.
Yeah,
so.
that's true.
Oh, it's pointing upwards, so.
Just a little. Just
Raise the backs to bring it level. See if that reduces the.
That would change.
Yeah, that'd give you the 16 feet, or give you a foot.
Yeah, tilt it.
It's amazing how that little.
Raise the back of
Yeah.
I
it.
got
A little
it.
vector man.
Raise the back of it. That's right.
I ran into that.
See if
when
it
I
gets
was
smaller.
doing-
Yeah, there
From
it
red
is.
laser?
There you go. Exactly. Great. 15,
Isn't that weird how it
16.93.
15.9. It's 16
Further down,
feet.
it goes further and further.
Down to 1 foot. What are you doing to me?
Trying to see the infrared light, but
Yeah, it looks like it could need to be calibrated.
It's pretty darn close.
Yeah.
So it,
Or using hand grenades.
yeah, it reports 35 or
Probably
30
has an offset.
centimeters, even when it's.
maybe
So yeah, if you're
ultraviolet.
that close.
Because it's
Okay,
not
so it doesn't
infrared.
go to 0; it goes to 30.
Yeah.
Yeah, gotcha.
It's not infrared. Okay.
I don't really know what
It's not
spectrum it
laser?
is.
Really laser?
No, it's not really laser.
I don't know.
It's some light, okay. Let me get a cheap camera on it. Your camera, you got highfalutin stuff.
No,
I don't.
You need to be in the back.
Well, hey, you can
Can you see
see
it?
the purple.
Purple?
There.
Oh yeah.
Do you see it as a purple?
Yeah, it's
Yes, yes.
purplish.
Yeah, I figured it was infrared. I wasn't real sure.
Well, purple would be ultraviolet, wouldn't
Ultraviolet.
it? Red would be infrared.
Infrared, ultraviolet, whatever. It's one of those colors we can't see. So.
Yeah, ultraviolet is the high frequency, infrared is the low frequency that you can't see. UV, now UV, is it a UV laser?
It's not. It's not like this.
Is it a focused light?
This is not This is not laser.
So it's a focused light then.
But there is a UV laser.
There is a
Used to
UV
be a
laser.
little more expensive.
Yeah, like my, I've got one
Well,
of
no
those.
UV, just violet laser. You can see it usually.
Okay.
They call it blue, but it's not blue. It's
Yeah.
violet.
That's, I've got a LED projection light.
Mm-hmm.
So I can see how they could project a beam easily. They just focus LED light
You know,
at
there's
distance.
there's a couple of
So
lenses
you can
on
do
there.
that easily. So it's just a UV or whatever light. It's out of the just happens the LED just happens to be out of visible range, which most LED lights that they use in lights are really out of the visible range, and they use phosphorus. They energize the phosphorus to give off regular light. Because if you use LED light, it's unstable. If you use 3 colors, they'll degrade in varying amounts. The red will degrade this amount,
Do you have something
and the
glow
green
in
will
the dark
degrade
stuff?
this amount.
Didn't know that.
Yeah, so now all of the phosphorus, all the stuff
I don't
they
think
use for
so.
lighting is phosphorus, or something they're exciting with UV, and the lights are actually UV. Very similar to the
Oh, you
fluorescent.
wanna see
So they're using the gas.
Glow in the dark.
Yeah.
Do what?
Using the gas in there, just like fluorescent.
LEDs,
The watches
I don't think
used
they
to
use
have some
gas.
You said
marks
phosphorus.
with glow in the dark.
Yeah.
Is that
No,
a gas
I
or
don't
a
think.
mineral?
It's a mineral.
Okay.
I don't think I've got
So
anything that glows
they're
in the
shining
dark.
I
the
like
UV light
this.
on
Into a
the
mineral.
phosphorus.
It's 99
And
cents.
it's blocking the UV light from going through, which it needs to
I
do.
will pass by.
And it's
they are-
energizing
they
Is
come-
that the phosphorus
Well,
that used
we
to be
were
in
walking
detergents
around
that they outlawed?
upstairs,
Yeah.
and
For
Similar.
you know that little
Yeah.
tool section that
If,
they've got
if you shine a
Where
UV
is it?
light
It's upstairs?
at
upstairs.
laundry
There's a
detergent,
little tool
it'll light
section,
up.
and I just
That's
said,
how, yeah.
I picked
if
it
you
up
ever
and
go
went,
into a bar
I want one of these
with
aside on my
with
computer
a
sometimes.
paisley shirt that's been washed in
Yeah.
soap, it'll light up
Here.
like a Christmas tree.
I'll get another one.
Wow.
Okay.
How did you know that?
I
He went in a
I
bar.
heard that.
He went in a bar with a
I heard that.
paisley
You've
shirt.
given me so much stuff, I can afford to give you 99
That he
cents
looked like
worth
a
of stuff.
freaking Christmas tree.
Can you? No, really.
So if you take a fluorescent bulb,
Only problem is
It's-
you have to
I
walk
figured
about a
this out
mile
when I
to get
walked into
another
the
one.
store, they had
Yeah,
a
well, that's
UV
alright,
light
we'll
for
be
the
down there
aquarium.
again, cause I gotta get a
And it
shelf
was a
and some
stupid
other stuff.
fluorescent light with no
This-
phosphorus in it.
This,
I
this
said,
is,
that's a
this is,
fluorescent light with no phosphorus.
it's good
I
to
was
keep
right.
him happy.
It puts out UV light
Yeah.
because
You
there's
have
no
the
phosphorus.
working the-
Same thing's happening in the
A
fluorescent
Radar
sweet,
bulb.
a sweet, yeah.
They're developing.
But they use
yeah.
a gas in fluorescent bulbs.
Nobody's really
Uh,
told me if
or is
I'm
it
starting or
phosphorus,
not
you
yet,
say?
so.
They're on.
The white sheet
Powder coating.
is a coating of phosphorus,
Okay.
and the gas inside actually has mercury in it,
Okay.
See what I'm
enough to
doing.
get some.
So that white powder that if you rub your,
That's phosphorus.
that's phosphorus.
And it absorbs the ultraviolet.
5
Yep.
minutes,
So
man.
those radiation.
They're doing the
So
same
survey.
thing they're doing with the LEDs.
So that's
Which they don't use,
statutory.
in a lot of detergents, they don't use
Upload a
phosphorus.
different sketch.
Phosphorus anymore, do they?
I don't know.
It was supposed to be bad
It's
for
half the size I
Well, they
thought
have,
it was.
Oh,
they're
it's
putting
tiny,
bluing
yeah.
in
Tiny,
a lot
tiny.
of the new detergents. I don't know.
borax and bluing,
The bluing is to make it brighter.
brighter, especially
What is
the white.
that?
I don't know if that's UV receptive or not. We need to shine UV lights on on our detergent to see if, and I've got some UV lights now.
Anybody still have powder detergent?
It's big again.
Oh, yeah.
You need to
the
scale the
Kirkland
second
Sheet
monitor
powder
or something?
detergent. I put it and shake it up in water so it dissolves a little bit before I dump it.
They won't give him the pods because they're afraid he'll eat them.
Eat them, yeah.
Yeah.
Well, when they
The
When
Motion
they,
detector
you have a
for
pet light, don't they use
aliens.
Gator.
phosphorus light for like urine lights for pets? Is that a purple light or?
It's
What's the
scanning
minimum
the-
distance,
oh,
sir?
okay.
30 centimeters. There we go. That's a little better. That's a little readable, more readable. Where are you at?
That real skinny one must be medium.
Something happened because it's not reading it.
It says close to, oh, it says 300, isn't it?
That big, whoa, that big pork chop one couldn't be me.
Is it out of range?
What the heck just happened? I actually saw it painting. I actually saw it painting dots there for a second.
It was. Now it's just, there it is.
That sees, looks like it's on the, putting up the opposite side as the.
Yeah, it says it's
structure.
out of range.
Oh,
Let's do this.
This means no data, or
Yeah, pretty much. Let's reset everything.
Rebooted.
you had the right COM port signing?
hit it the Windows 10 reboot.
Well, Windows 10 is always a problem.
It's whatever version of Windows you're running, that's what it happens.
There we go.
Okay.
It freaked out. I don't know why.
Like there.
Like there.
What are those dots
It did
again?
again.
There, Leroy?
So when it actually is working, the dots.
Tom?
They're not showing them now. They
No.
were a second ago.
This is actually pretty simple.
If you were by night in a plane, you were already dead.
Do what?
If you were in a plane,
Yeah,
by
we're
night,
dead. We're already dead. But it goes from 0 centimeters to 300 centimeters, from 300 centimeters to
480.
480, all the way up, and then anything past 860 would be the 1200, and that was the best I could get it to display. It's actually scaled. The Arduino sketch scales it down because this processing sketch is an old ultrasonic sketch that the guy was doing ultrasonic, and he was only going up to 40 centimeters, which seems pretty small. I'm going to reset this again. I'm not sure why it's going out of range or why it's not reading it.
Yeah, it showed those dots for a second.
I'm sure all the wires are.
Looks an awful lot like the aliens motion detector.
why you use this instead of servo library?
Okay, so this is a pulse width modulation board.
Mm-hmm.
The servo library has some timing issues, and the LiDAR sensor works with just strict serial
Okay.
at 100 and what is it, 150, 1,150. Yeah, that one. 11,200. Yeah, a lot. Fast.
Yes, fast.
Fast. So anyway, with software serial and the servo library running, there were huge timing
Software
issues.
serial, okay.
And when I read that there were even some timing issues at that speed, at that software, at that speed with the hardware serial port and the servo library. So I decided to use the pulse width modulation board to try to overcome that, but now it looks like that problem has crept back in. So, because that's what it looks like it's doing. It looks like it's messing with the timing again.
Larry, how you doing?
There's more to choose from?
So, I don't know. You can't really see it right down here, though. It's reading. It's actually will tell you the distance. And
It simulates the persistence of the phosphor monitors.
you know what? There may be a. I had suspected a power issue with this thing the first time. Let's try to just.
So,
Try to just do this.
what are the red dots again?
Us.
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 Whatever it sees.
No, but
Okay.
they are very far from.
That big red dot was me. The red dot with the big black cowboy hat?
We are closer than 3 meters.
What?
We are closer than 3 meters.
Uh-huh.
And all the red dots are far from the 3 meters arc.
Let's see if it's a power
There's
issue.
us. A lot of us out
Okay,
there.
that's
looking better.
that's showing the wall, I guess, somewhat.
Yeah, that.
I
now,
suspect
yeah.
a power. I suspect this thing is a little.
Moved by Santiago.
It probably needs some bypass capacitors.
What happened with the square of the
Power
room?
supply. Okay, so I think it's seeing the wall. That's not and the desk.
Well, part of
Where
it's
the
seeing the
continuous
laptop.
dots are, that's the wall.
Well,
So,
It's consistent.
so we can see what angle the servo's at, more or less. It goes from 30 degrees to 160-ish degrees, and then we can see right here that is cool. That's why this thing's got some sort of sensor for. I'm turning the volume up on the TV by pointing at it, but you can see the.
I think that, well, this is impacted, but look, the glasses
That's all the way down here.
doesn't return the signal
Yeah.
in this side.
Yeah. Yeah.
You can see the wall of this side.
Yeah.
This is
Well,
this wall.
okay.
Look
and that
look
wall
way down here because
Okay.
It's close, yeah.
at 30 anything at 30 centimeters is going to show up at the 0 point.
Okay.
And you watch, it shows up right there at the dot, right at the center.
Looks like the now.
So
I think that the glass.
I think
affect
it is, but if you look at when it's pointing right at the laptop, there's a dot right at the center.
Yeah, it's at the side, yeah.
because when I scaled it to actually make it display something that was okay,
Looking.
I said 30 centimeters is really 0, and
So when the dot's
1200
down there, it's scanning the laptop.
yeah. So that's the 0 point is right at the center, right there, the 90 degree and the bottom line conversions. But it's definitely seeing. There's definitely like a wall or a bunch of objects right in a row, which I can pretty much see that.
The wall of the.
It's kind of hard to know what it actually is seeing because it's just dots. But I borrowed this. This is a processing sketch, and I borrowed it from a project that
Ultrasonic radar.
that was doing the ultrasonic radar, which was really more like sonar, not so much actually had the red lines going clear. I changed it to a dot. He had the red going clear up.
Change the color and goes to the end with the color changing.
That's transparent, so it may not see
No,
it.
yeah, it's. Well,
Stick a book up in front of it. I mean,
little document
no,
way down
close to it. We wanna see something bad.
under
So-
300.
The spec sheet for this says that it's got a 2-degree angle on it, but the further away the angle gets a little bit out.
What's the angle?
It was 2 point something degrees. So that's pretty small. It's pretty tight.
Let's
Yeah,
see if
it's
it
nice
sees
stuff.
that. I wanna see a big, something big pop. Yeah, okay.
So if you actually pointed at something big,
Just figured out how to stump it.
Yeah,
Flat
still.
top lid on a slant.
Mm-hmm.
I think that's pretty cool though. Spec sheet.
Now the real trick is how do you
2.3 degrees.
figure out what all
That's
the
a pretty
dots are.
tight.
Yeah. Yeah, it stays the same rate, you can't slow it down.
I probably could slow it down if I really wanted to.
Okay.
Is it
That-
going?
No, I just didn't know if you could play with the speed,
Oh yeah, I probably could.
if that would it.
How many measurements do you have per second?
So if we stop the processing sketch here, let's see. Stop, and we go to this, and we go, and we look at that. It won't make any sense what it's actually doing, but it's like back to back to back to back to back to back to back. So it's sending an angle and a number, and there's a comma between the angle and the number, and then there's a period to
Yeah, then
to
mark,
say
to
that
mark
it's done.
the end of the frame.
Yep. And I didn't change it. The only thing I really changed in that was,
Sensor.
well, I changed quite a bit to get it to work, but the only thing I really changed, that's not the right sketch. That is the wrong sketch. The only thing I really changed was, the fact that I am now mapping
Okay, yeah.
the angle out so that it, instead of going from 0 to 40 centimeters, is going from 30
Yeah, yeah.
centimeters to 120 or 1200 centimeters. And that's really the only thing that I changed. So really, I guess in reality, when it says 1, or when it says 0, it's really reading like 1 centimeter, but this wasn't supposed to be like precise. It was just supposed to show a neat little picture. Then the processing sketch, I didn't really change the processing sketch at all. I changed a couple of things. because he had it drawing a line clear out in red when it would detect something, and I changed that to a point if I can find it, and then I changed. He had his array was 0. No, it was 10, 20, 30, and 40 centimeters, and I changed that to reflect my distances. But other than that, I really didn't change much. I'm not real sure where the point thing went. I changed. I changed the screen resolution for my screen, and then tried to change it again for this screen, but even the line that where I changed it from line to point, I think all I did was actually just change it. I actually think I just took line out and put point.
Can you make that code bigger characters?
I don't know. Maybe.
While we're here.
I can kill that first, because that's in the control.
Control plus?
Control plus. Control plus.
If that's the IDE, it wouldn't do that. That's processing IDE. Okay.
It's not doing it. I'm not real sure where I changed that point thing at though. But that was really the only change I changed my numbers, and I changed the line to point, and that's really the only change I made to the processing sketch. I had to use this little PWM board. Can actually handle 16 servos, up to 16 servos, and you can actually daisy chain it and get it to use more servos. It works I2C, so it's only taken a couple of lines. As long as you get a good power going into it, it seems to solve the problem of the whole timing issues, which is a good thing. The only weirdness about it, and I'm not entirely convinced that it is actually weird, instead of drawing power from the Arduino to drive the servos, you have a separate 5-volt line to do that. And if you're driving 16 servos, you want to do that anyway, so because the Arduino won't deal with that very well. I ran through a couple of like minor things. The first time that I saw it, I ran the first sketch that showed just the numbers, the distances, and I was like, okay, cool. And so I loaded up the servo sketch, and it stopped working, and I thought, well, maybe it's a power issue. So I tried that, and then I said, I eventually got to the point where, okay, it's got to be a timing issue, and then I was walking around at IKEA at all places, and I remembered I actually had that board. I had never used that for anything, and so this was a good project to use it for.
The real name is time of flight infrared
Yes.
wrangler.
So
don't use laser.
Okay.
It does not use a laser. That is something though that
Infrared range finder.
well, it's still technically a LiDAR because there's two different definitions to LiDAR, and one of them is light, and one of them is laser. And SparkFun says that it's a time
Yes,
of
I'm
flight.
reading what the smartphone is saying.
Yeah, SparkFun says it's a time of flight sensor, which it is. But when you go and you look up what a time of flight sensor is, one of the things that it references back to is a LiDAR. So it kind of goes in this vicious circle. It's still technically a LiDAR because it does use light. We just can't see it, and it's not a laser light. One of the references I found actually said, um, I don't remember if it's the LiDAR reference or the time of flight reference, but it actually said it could use either laser or
Light.
LED light. Yeah, so. But that's technically what it is. It's technically a time of flight sensor. So it's both direction. It sends a pulse of light, waits to get that pulse of light back, and it goes, divides it in half, and goes, okay. So it's a pretty fast sensor because the speed of light is really fast.
So I don't see any video on this. So where's the video? Is that being generated on the PC?
Yeah. Yeah.
Within the IDE, they let you create a.
So processing, I don't use processing much, so I don't know a whole lot about it. But processing, it was designed for generating like graphs and menus and
User interface.
yeah, and so
Processing is where the Arduino IDE came from.
Yes.
yeah,
Originally, the same
yeah,
idea.
the two are related to each other. They're like distant
Supposedly
cousins.
was designed for the artist to create moving images and manipulate objects and images and in the screen. But you have all kind of libraries to do whatever you want.
And processing
Plot graphics or whatever.
that particular processing sketch was in Java, and you can add more different languages. I'm not at all familiar with Java.
Android applications.
Yeah, you can do all kinds of stuff with it, but processing was basically it handles the serial events really well from the Arduino or any other microcontroller that can talk serial, and that's basically what it was made to do, is display stuff. So
There you go.
easy. And besides, like most things, when I first I believe I first talked to him about it, I said, well, yeah, I know of the ultrasonic radar project. I bet we could just make it work with the LiDAR. I mean, how hard could that be, right? Week later, a little harder than I thought it would be, but a week later it was done. So I don't know processing very well. I don't know Java hardly at all. I knew enough. Googled with my friend, and I went, well, how do you do this? What is this? how did everybody like my mounting?
Yeah.
The rubber band's nice.
Yeah. Okay.
So I got the LiDAR sensor on eBay. I think I posted a link to it. I think it was like $35. It came with a funky little connector because it was actually meant for a quadcopter, not for what I used it for. But I made my own little connector for it, and it works fine.
Power and one serial.
Yeah,
line.
you only really need the receive line. I think you can send the commands as well. I haven't really read the data sheet that far, so I think you can tell it to do other stuff. But for what we wanted to do, Um, but that was really the only. The Spark Fun. It's the same lidar sensor, but they actually give you a cable that is actually usable for $39. So I saved myself a few bucks, but had to deal with the cable. So.
So what would be the practical application for that? I know there's many, but.
Well, okay, so like because of its great distance, because this will go from 30 centimeters to 12 meters. Um, I was actually thinking, this might actually be good for the robot to be able to scan out pretty far and then come up with an algorithm to kind of drive through there. And you'd still use the ultrasonic just in case something changed as it got closer or below the 30 centimeters.
I guess
30 centimeters is 12 inches roughly.
Right.
So, that's a whole foot. So your robot still has a lot of room to run into something at that point. I know they use these in the quadcopters for pretty much the same reason, only, the quads run a lot faster. So, you could easily get to that 36 foot in that amount of time. And once you get to the 30 centimeter thing, you just say, I'm stopping.
Right.
Because that's like a foot away.
So if you upscale that and say, okay, it's a bigger unit, you could possibly measure a room, for example, on all the walls. Just stick it in there and say, okay, measure all the room.
Possibly. Nito, I don't know if anybody, I know I told you about it. Nito,
So they have different brands of LiDAR.
now Nito is a vacuum cleaner,
Oh.
but it actually uses a spinning lidar, and it's a real it's a real laser kind of deal. This is actually, um, so like if you see like the Google
Right.
cars out,
Right.
or the
The little.
the Apple
Yeah.
trucks out, they're using a bigger, better version of it, but that's basically what they're using is the spinning lidar. You see the price?
Mm-hmm.
$145.
And this is usable.
$39. Of course, that's a much better. It this lidar, this particular lidar still is a serial device. So you plug it into your thing, and as long as you know how to read the serial string,
Mm-hmm.
you can still do the same thing.
So let's talk about the Google LiDAR system. Okay, so they're taking pictures, right? So the LiDAR is actually their sort of, I guess, I don't know, longitude, latitude is maintaining measurement.
It's a very precise measurement.
Right.
Um, so they're using it for distance tracking. You can use lidar for all kinds of
Right.
different things. Um, the cops use it for speed measurement. I was actually thinking about that for this because I think we could probably do something as long as it was coming at it or going away from it, and it would be a time thing. So you take one reading and then immediately take another reading, and that amount of time you could see what the change was. And probably with a little bit of math, you could probably figure out how fast that thing's actually moving.
Yeah, I mean that makes sense, for I guess what like the police use, the radar. It's in flight, move, come back. But you're doing this cone thing, so you're actually, scanning, right? So it's like, when you think about,
Well,
go ahead.
if I was doing this, if I was doing this for on the robot, it probably would be fixed, like to the front of it.
Right, exactly.
Um,
So, okay, here's an example, I guess, if you're looking for an opening in a room, I guess, would be an example, okay? You wanna make sure it gets to the opening out at the door, so it's sort of scanning, so that, I'm just trying to get there, really, I'm just, just talking it through, because I've never really thought about it, I've heard, I've heard the name, but I've never really thought about the practical use of it.
oh, there's a ton of uses. It, I don't. See, I don't know how I would do it if I was put, because
Right, if you put it in a
ultimately
robot.
I'm going to put this on a robot, but I don't know if I wanted to do a sweep or if I wanted to just point straight.
Right.
Um, but either way, I mean, if it's doing a sweep, you can create a map inside the
Right,
robot and
exactly.
say, this is
And I don't know if
here.
you remember that, I mean, who's the other vacuum cleaner, the big one, the big guys in the vacuum?
iRobot.
iRobot. I mean, they were actually taking that data, mapping people's houses, so they had all these data maps of how people's houses were laid out. So I assume that they're doing that scanning.
iRobot and maybe the recent versions of iRobot, the early versions didn't have any kind of mapping. They were just a random.
Right.
They just had random patterns to do it. Nito really was the first one that actually generates maps.
Yeah.
So.
Yeah, I know it was a big stink about that, and I'm pretty sure it was iRobot that actually.
iRobot was the first robotic vacuum cleaner, but they're probably not the best robotic vacuum cleaner.
Yeah.
Looks like iRobot's patent or whatever is running out, their royalties or whatever's running out. Cause this A4 that I got, it's a knockoff of iRobot. Absolutely.
iRobot is focused on military applications right now. I don't even think. I mean, I know they're still making the vacuums, but I don't really think they care about that too much anymore.
They got the higher end. They got the 800, 900, and the mapping the room stuff. Everybody's starting to do that now for the higher end. Hopefully it'll come down to the low end. I got the knockoff of the original. Okay.
There is actually.
You brought that in once, didn't you?
Yeah.
Yeah.
There is actually a knockoff of the Nito that is it's I think it's $200 instead of $700, but it uses the same lidar, so it's kind of like,
They showed a comparison. That guy that did the A4 also did the A4 compared against the. He had one with this on the top of it, and he had a comparison, and he compared, and the A4 was cleaner, but this unit would clean faster.
Okay.
But it'd taken you an hour to clean with the A4, hour and a half, and the other one would clean in 20 minutes. Just not as clean.
Yeah.
But I'm sure they'll just get cheaper and cheaper. Hopefully the units will be less than $145.
I think like some of the applications that he's probably interested in for like an autonomous automobile.
Right.
I think lidar probably would be really good for some of that, and I'm sure that they're using it because it's relatively inexpensive, even at $150 level.
Yeah, that's a good example of that. Because I mean, you don't want to keep track of cars next to you, behind you. If you're too close to the car.
The new brake system that they've got, where the cars can start slowing you down.
Right.
They're probably not using that, but
Right.
they're probably using something very, very similar to it.
Yeah, I wondered if, in those cases, do they actually have a non-mechanical scanning? You know what I mean? Because I mean that the speed of relying on mechanical scanning would probably be too slow.
Right.
Yeah.
Yeah. Well, that's why even on my robot, I'm not real sure I would
Right.
do this because it's not fast. Even it's not fast. Even though the sensor itself is
Yeah.
really fast. Now, I do own one of these that I've never used and it's in storage and I have no idea where it's actually at in storage. But that I would use to make maps because that's already designed to spin and
Yeah.
do everything that it's supposed to do. But I have no idea where. I have no idea where that is right now.
What's the distance on that one? You know?
I would have to look. It's probably about the same,
Really?
30 some odd feet. Because I know they can map a whole room, and I've seen videos where it maps a whole room. I bought a broken Nito robot for like $50 just to get that. Because look at that price. $50 was cheap. And then I threw it in a box and
Forgot about it.
that was the last I saw it.
You know, one of the things they talk about all the time in the IoT world is and it's a very crude application, but they always talk about knowing that your conference room is empty or occupied. You know, so I mean, they always sort of bring that up for some reason when they're talking about the demonstrations. I guess that's a big thing with big corporations, knowing, you know, when